as we begin this first module, we are going to start with our laws of exponents. What I want to do first, before you start reading through the ebook, is I want to just show you some patterns so you can kind of interact with these before you actually read the formal rules and formal definitions. So I have a list of powers of 2 here. And what I want to focus on is what happens when our exponents become 0 or when our exponents become negative. We should all be familiar with positive exponents. For instance, if I have the expression 2 to the 6th power, we should know that 2 is our base and 6 is our exponent. So that being said, 2 to the 6th power means I have 6 factors of 2 multiplied together. So the exponent tells me how many bases I multiply together. So 2 to the 6th power means I have 6 factors of 2 being multiplied together. And this gives me 64. So 2 to the 5th power means I have the factor of 2 5 times. So I have 5 factors of 2, which equals 32. 2 to the 4th power, I have 4 factors of 2, which is 16. 2 to the 3rd power, I have 3 factors of 2, which is 8. 2 to the 2nd power, I have 2 factors of 2, which is 4. And 2 to the 1st power, I just have 1 factor of 2, so my answer is 2. So the first pattern I want you to notice is that as the exponent decreases by 1, so we went from 2 to the 6th power, 2 to the 5th power, 2 to the 4th power, and so on. As the exponent decreases by 1, when we look at our expanded form, this is the expanded form right here. When we look at the expanded form, each time I'm decreasing by 1 factor of 2. I started with 6 factors of 2, then I had 5 factors of 2, then I had 4 factors of 2, then I have 3 factors of 2, 2 factors of 2, and then down to 1 factor of 2. So each time I'm taking away 1 factor. Well, taking away a factor is just like dividing. So if you look at our results over here, when I went from 64 to 32, I did 64 divided by 2, because I lost a factor of 2, or I divided by 2. When I went from 32 to 16, I divided by 2, because I had 1 less factor of 2 to multiply by. 16 to 8, I divided by 2. 8 to 4, it was 8 divided by 2, and from 4 to 2, we did 4 divided by 2. So each time that we decreased the number of factors, each time that we decreased by 1 factor of 2, our final answer was divided by 2 to get us our final answer, because we had 1 less factor of 2. Now, that brings us to here. So what would happen if I continued the pattern and I have 2 to the 0 power? Notice how my exponents have been decreasing by 1. 6, 5, 4, 3, 2, 1, and now we're down to 0. Well, this part right here is kind of abstract. You're kind of confused. Well, what do I put there? Do I put 0? Lots of times students think it should be 0 because they're thinking 2 times 0 is 0. But we're not doing 2 times 0. This is 2 raised to the 0 power. So to figure out our answer, we need to go to our pattern. If I did 1 more, 2 divided by 2, I would end up with 1. So if I divided by 1 more factor of 2, I would end up with 1. So this is our first rule. Any number raised to the 0 power is going to equal 1. Now I'm using B for base. So any base raised to the 0 power equals 1. Except for when the base equals 0, because then you have something that's undefined, but you'll see that as you read the book. But what I want you to see here is our first rule for 0 exponents. Anything raised to the 0 power is 1. And it would work no matter what my base is. I could change these 2's to 3's or 4's or 5's. Every time I divide by 1 more factor, I would eventually hit the number 1. So now we're into our negative exponents. Well, then what does that mean? Okay, if I have 2 to the negative 1st power, well, how many factors of 2 do I have? Well, again, we need to go over here and look at the pattern. If I keep my division by 2 going, 1 divided by 2 gives me 1/2. You could also write it as 0.5, but we see the pattern better if we leave it as a fraction. So 1 divided by 2 is 1/2. If I divide that by 2 again, now I have 1/4. So over here, 2 to the negative first power, that's 1 factor of 1/2. 2 to the negative second power is 2 factors of 1/2 to give us 1/4. 2 to the negative third power, hopefully you're seeing the pattern here. If I divide by 2 again, that gives me 1/8. That means I have 3 factors of 1/2. 2 to the negative fourth power, again I'm dividing by 2. That gives me 1/16, which means I have 4 factors of 1/2, and the pattern continues. So as my negative exponents get smaller, negative 2, negative 3, negative 4, negative 5, negative 6, those exponents are getting smaller. My factors of 1/2, the number of factors of 1/2 are increasing. So 2 to the negative fifth power would be, you guessed it, 5 factors of 1/2, which would be 1/32, again, because I'm dividing by 2. Now, again, like I said, let's notice the pattern. Notice how these are matching up. This 2 matches up with the 1/2, 4 and 1/4, 8 and 1/8, 16 and 16. So what I'm seeing here are reciprocals. 2 to the fourth power was 16, right here, but 2 to the negative fourth power is 1/16. So notice how when the sign of the exponent changes, we get the reciprocal. So let's finish this off with 2 to the negative sixth power. That means we would have 6 factors of 1/2, which, you guessed it, would be 1/64. Okay, so that brings us to our next rule. So let's look at this again. Let me recopy this. So I had 2 to the fourth equals 16, and 2 to the negative fourth equals 1/16. Well, notice that 1/16, that's the same as 1/2 to the fourth. So when I have something raised to a negative power, it's the reciprocal of that same base, but raised to the positive power. Again, let's grab another one. 2 to the negative third, just to see the pattern. 2 to the negative third was 1/8, but that's the same as 1/2 to the third. So notice how our power with a negative exponent turned into the reciprocal, and the exponent becomes positive. Okay, so these are 2 of our rules that we are going to learn in this first module, zero exponents and negative exponents. You're going to read about them in the ebook, but seeing these patterns is really helpful before you actually go and read all the definitions and the actual rules. Before you go, we are going to do some examples. Okay, so I have some basic examples here using these 2 rules that we just learned. So 5 to the 0 power, we just learned anytime a base is being raised to a 0 power, our answer is 1. Now, as we do these, I want you to keep this question in mind. What is the base? Okay, you want to know what is being raised to the power and what is not, because it's easy to get fooled here. So in 5 to the 0 power, my base is 5. So 5 to the 0 power is just 1. But in negative 5 to the 0 power, which we can also read as the opposite of 5 to the 0 power, my base is actually 5. And that negative sign comes from multiplying the result by -1, just like saying the opposite of. So this negative sign right here, you could also say the opposite of 5 to the 0 power. Well, in 5 to the 0 power, the base is 5, so 5 to the 0 power is 1. So this final answer is -1. So this 5 to the 0 power here is that 1, but then we multiply it by -1. In this next example, with the parentheses, since the parentheses are around the negative sign and the 5, that means the base is -5. So we have one base raised to the 0 power, so that's 1. All right, let's look at this next one, 5x to the 0 power. only x is being raised to the 0 power, and then it has a coefficient 5. So this is 5 times x to the 0 power, which is 5 times 1, final answer 5. But in this next one, where we have parentheses, the base is 5x, and the whole base is being raised to the 0 power, and nothing else is being multiplied, so that's 1. All right, let's look at 7 to the negative second power. If we use our reciprocal rule, that's 1 over 7 to the positive second power, which would be 1 over 49. Here, we have negative 7 to the negative second power. Again, that's like a negative 1 being multiplied to 7 to the negative second power. So in this case, my base is 7. So the only thing I'm taking the reciprocal of is 7. So this is negative 1 times 1 over 7 squared, which is going to be negative 1 over 49. Now here, my base is the negative 7 because it's in parentheses. So I can go ahead and take the reciprocal. So this becomes 1 over the base of negative 7 squared, which is still 1 over 49, because negative 7 squared is still a positive 49. All right, x to the negative first power, that's 1 over x to the first power, or just 1 over x. X times y to the negative first power. My base is y. X is not being raised to the negative first power, so only y is being raised to the negative first power, so I only take the reciprocal of y. So this is x times 1 over y, which becomes x over y. All right, 3x to the negative first power, only the x is the base. So this is 3 times 1 over x, which is 3 over x. Now, in this last one, my base is 3x, so it's the reciprocal of the whole thing. So this is like 1 over 3x to the first power, or just 1 over 3x. So notice how in these two right here, when you took the reciprocal, in the first one, since 3 wasn't part of the base, 3, you don't take the reciprocal of 3. 3 stays up in the numerator. Whereas here, your base is 3x, so you take the reciprocal of both. It becomes 1 over